uh, yeah, did the work, did a fair bit of work, as you will know. Um, the holdup was, of course, on the bureaucratic side, so for the last year or so, right? But finally, we seem to be here, So, yeah, I think we can get done with the last step in the whole thing. So I think everybody else perhaps knows Archana, right? At least as far as I see. So no need to introduce to her to anyone. But yeah, in case Archana. So we can get started. So one small suggestion, Archana. So I think, of course, I went through the slides. What I would say is, at the beginning, you can kind of focus or just allow more time for that JIS and JIMI, that because that sort of was the you can say the main part of the discussion. So in as a reference, if you have a slide, I don't know if you have changed, but the one you sent me, it's numbered slide 11 out of 62. You have a tree diagram, right? So the what can you say, the lower branches of the tree can just allow more time, and I'm sure there will be time. So then you can get into the other contributions. Of course, all
Yeah.
our collaborative work, it's just to ensure that we don't we allow enough time for the main part, and if at all we have to sort of crunch time, let it be on the other subsequent ones, right? So
Sure.
that's it.
What I have done is I have weighted equally. I mean, a large portion of it is actually talking about JIS and JIMI,
Mhm.
and the remaining portion basically talks about the other content, and indirectly they are connected to each other. So, yeah,
Yeah.
point taken.
Right. So no, the reason is essentially if you follow like the tree diagram from the root and go upwards, that's pretty much it. But
Yeah.
obviously, all these things would have not been linearly done. So some slides are your slides are mostly in the chronological order. So I mean, generally, it's not a good idea to sort of skip slides and go back and forth. But I
Yeah,
understand
yeah,
because hardly you
yeah.
had a week, right? I didn't have much time to go through and give suggestions with enough time. Let's
That's okay.
since VTU has given this historic blessing, right? Let's get done with it before anything comes up. So I understand that you followed the chronological order. So at least I'm okay with you sort of skipping slides and coming back to them if there's time. So more or less follow the from the root to the upper branches. That will be the thing. Okay.
Yeah. So,
Okay.
Anand sir, as you said, this is what will be happening. So, it's a bottom-up approach. So, the
Okay.
lower branches will be covered first, and then the top branches will be covered. And
Correct.
I don't think there is any need for me to skip these slides and all. Everything is in continuity. I think shouldn't be a
Correct.
problem.
No, in the sense, suppose we are the discussion went longer, right? Let it go longer on sort of the main portion of it, and if you have to skip, say, skip a proof, right?
Yeah, yeah,
So
yeah.
that's
Yeah, yeah, yeah.
sort of thing.
That point taken. Yeah, yeah.
Yeah.
Obviously, not
Okay.
possible for me to cover everything. I
Yeah.
might have to. Yeah, sure.
Okay. So, okay. Okay. So over to you, Archana. So I think we can get this network is a bit flaky. Hopefully it will hold up. But meanwhile, Snehansh, if you can capture screenshots for posterity and for VTU, right?
You know,
Just
of course. Yeah,
yeah.
already
This
done.
I've
It's already
connected
done. The
to.
recording
Okay.
is also on. So Archana,
Oh,
you can
great.
start.
You can please
Sure.
start.
Okay.
Yeah. Okay.
Sure. Okay. So, let me share my slide first.
Also, guys, just 1 minute. So if you have a question, I would encourage you to type it up on the chat box so that when Archana is done, she can take the questions one by one. Okay.
Yeah, I think
Thank you.
that's a good idea.
Yeah.
Yeah.
Thank you.
And yeah. So I'll anyway independently open that up also just in case. Yeah.
Yeah, okay. So, good afternoon, everybody. Thank you, Anand sir, for introducing me. Thank you, Dr. Saha. I think in this span of 5 years, you have guided me enough number of times and scolded me, and also gave your feedback whenever you could. And thank you everyone who is here today. So time to begin my defense now. And good afternoon to everybody. So as Anand sir just now said, what I will be doing in my presentation is I'm going to divide my time into different things. So most part of my time will actually go in covering the main PhD problem that has been solved, and good amount of time will also go in covering some of the things which were developed after this problem was solved. So with that note, let me begin. So the title of my PhD thesis is A Novel Hybrid Machine Learning Approach to Model and Quantify the Internationality of Peer-Reviewed Journals. So I was guided by and co-guided by Dr. Anand and Dr. Snehanshu, and giving a very quick overview, basically, I gave the entrance exam, the PhD entrance exam in 2015, and pre-PhD presentation was also in 2015. 2016, I got registered. 2017, I cleared all the subjects. So these were pretty much the subjects which I took: research methodology by default, and advances in knowledge data discovery, a very interesting subject, very close to data mining. Web intelligence technique was also good, but very theoretical, and linear algebra was definitely the very important pillar of this entire journey, because most of the concepts of machine learning were basically involved from linear algebra. Coming back to the previous slide, I also want to give the introduction to the thesis title, the work which I have done, the work we have done together, and the proposed approach, computation of the parameters like JIS and JIMI, the final internationality score, and then the fourth point, which is talking about building the theoretical concepts of machine learning post the fact that we were able to come up with the solution to the problem. Right. So in in these span of 5 years, we were able to publish 3 book chapters, 5 conference proceedings, and there were 12 international journals. All of them were Web of Science indexed and either Q1 or Q2 rated. So these are the 3 book chapters. Maybe I'll skip this because there's a lot of information in this. And now these are some of the journal publications, beginning from Scientobase and DSRS. As we can see here, Scientobase and DSR, these are the most important work which was done as a result of the completion of my thesis. There are a few more. I'm just very quickly skipping them all. And coming to the title pretty much says that a novel hybrid machine learning approach to model and quantify internationality of the peer-reviewed journals. So basically, just to give a quick background of what happens in the domain of scientometrics.
Sorry to interrupt very quickly. I think most of them anyway know or have many have even collaborated. But for those who haven't, so this problem is what she'll mainly spend a decent amount of time on, 50 to 60%, but a lot of some of the techniques and some of the offshoots of that technique were applied to other problems and other in other domains as well. So she has ended up doing a fair bit of work. So and that publication list and all of that actually covers all of them. So they're all part of the thesis, but just in the interest of time, we will focus on this problem and the related ones, right? And in the remaining time, the offshoots. Okay. Yeah, go ahead.
Sure. So yeah, thank you, Anand sir. So basically, what the title says is, I think most of the audience are aware of the scientometric domain, and they have worked in the domain of scientometrics and how they pretty much work. But I think I will still like to go and give a quick background of what exactly is a journal, what is the process of peer review, what basically is internationality, and what basically we are trying to solve. So not going into the details here, but if I want to understand, see, we all are basically from academic background, And we also have a responsibility in terms of research along with the academic responsibility. So when this responsibility comes into our into our one of the jobs, then the most important thing is the publication. So what exactly is publication? What is a journal? A basic definition, a very quick definition of journal is an academic journal or a scholarly journal is basically a periodical publication in which the scientific work of a scholar is basically published. So another very quick background, basically any journal. The journal basically has an editorial service, and in this particular editorial service, they have editor-in-chief, associate editors, peer reviewers, and basically they follow a pattern, they follow a protocol before accepting a particular manuscript for publication. So what they pretty much do, when an article is received, when a manuscript is received, editor-in-chief allocates two or more than two reviewers to gauge the credibility and authenticity of that particular manuscript. So they do a very critical analysis of the manuscript, and then a feedback is given to the editor-in-chief. On the basis of that feedback, a decision is usually taken. Decision to accept for publication, to accept the manuscript for publication, or to reject it, or to do some revision, major, minor, and then it goes ahead. Okay, so with that background, it is also important to know what is internationality of a particular journal. We know what journals are. We know there is a peer review process which happens. So what is that internationality that we are talking about? So assume that I am a researcher. I am new to the domain of research, and I am ready with my work. And since I am new, I want my work to be published somewhere. So I will look out for some international journals, International Journal of so-and-so, International Journal of ABC. And since the most instinct feeling which will come into our mind is that the journal is international, and hence good to go with. Hence, I can always rely on the fact that the international tag is associated with the journal, and it is actually good to go with, and I can always refer to. But what I do not know is that the journal which is tagged as international may or may not be international at all. Okay, so how do I know? How do I know what is the reputation of a journal? Okay, so there are some databases, there are some schemes which are already existing. In fact, if I really touch the background, then 75 years back, there was a concept of citational database which was started by Eugene Garfield. And this concept was then taken over by Thomson Reuters. These Thomson Reuters and the company basically process the citational information, and they publish their information in the form of journal citation reports. So Web of Science, which we know today, basically is owned by Thomson Reuters, and this is how they evaluate the influence or importance of a particular journal. Very recently, Scopus is also now in the competition, and Scopus is basically owned by Elsevier, and they also publish their findings about the journals. And how do they publish it? Basically, there's a web portal with the name Scimago Journal and Country Ranking Portal, and that is where they publish it. Right. So I can always look upon these citational databases to say that, okay, this journal is good, this journal is bad. Good. But the problem is when it comes to knowing how international that particular journal is, till now, nobody has touched that. Right. So with this in mind, with this particular thought, it becomes important to at least identify certain parameters using which we can quantify, model, and measure the internationality of peer-reviewed journal. And this is what we have done in our thesis. And this is what I'll be talking about. Okay, so the problem definition very quickly, if I want to talk about, then we'll be identifying the parameters, and then we will build a model. We'll develop a model that can evaluate the internationality of the journals. Okay, so as you see the big picture, there are two phases. In the first phase, the identification of the parameters which are gauging whether a particular journal is international or not is done. So those parameters are identified. Then we had spent good amount of time in identifying the right model which can give us a score to measure the internationality. So very quickly, in detail, I'll be covering later. The model with the name Cobb-Douglas production function is what is used to model the parameters in order to evaluate the internationality. Then once the score were achieved, we were able to rank those journals on the basis of internationality. And then we were also able to classify those journals into national, international, and they were even finer granules where we wanted where we wanted to measure the internationality into low, medium, and high levels. We also wanted to investigate the growth pattern of a particular journal for specifically niche areas like astroinformatics. Right, so that covers my phase 1. In this phase 1, we got to understand the production function as a model, and we could analyze the critical functioning of that particular, and we were able to see the analytical structure of this particular model. And inspired from this particular model, we began our phase 2. In this phase 2, we come up with some machine learning tools, methods, completely written from scratch with a theoretical understanding as well as the empirical and analytical understanding. So we proposed kernel functions, we proposed activation function, and then we've investigated further and brought into building up frameworks where we would want to see from what is the origin of the activation functions which are coming, and it will go on and on. So we also wanted to build networks which can adapt the parameters from the database. So this will be my phase 2. So as very quickly, phase 1 touches upon the quantification and modeling and scoring and ranking and classifying the journals. And frame 2, the phase 2 will talk about the frameworks where we can exploit the analytical structure of the model and come up with new theoretical understanding. So that was the tree diagram I think Anand sir was talking about. So that's how the thesis pretty much looks like. So as you can see, this part of my work is all about computing the internationality score, where we have devised 2 new metrics to measure the influence and internationality of the journals. Inspired from the model, we came up with kernels, activation functions, and certain frameworks to understand the origin and existence of the current activation functions. A small portion of work was done to measure the lineage independence of the authors using particle swarm optimization, but I don't think I will have time to cover that. Okay, let's now dive into the details. Let us pick up questions and let us build the motivation of why do we want to gauge the internationality. So, okay, I'll just give an example here. Only yesterday, I just typed how will we define internationality of a particular journal. There was a question typed in the research gate, how will we measure the internationality of the journal? There were n number of responses. Okay, the most liked response was a journal should be called international if it has the editorial board members from different nations. One definition. Few said that reviewers. So assume that there are 3 reviewers which are allocated, which are assigned to a particular article. Then if the reviewers are from different nation, we say that the journal is international. There were few more definitions. If we, few more answers which they said. Few said that if the contributing authors are from different nation, well said. And a few others said that we do not know how to know whether a particular journal is a national journal or international journal. And that is good enough for motivation, because most of the people will either wrongly think that a journal should be called international only if the editorial members or authors or reviewers are from different nation, or they will say we do not know, we do not even know how to say whether a particular journal is international or not. So with that, what am I saying? Are we saying that we have a different definition from all these concepts? Yes, that's what we are pretty much saying. So how do we say a particular journal is international? So according to us, according to our definition, we say a journal is international. We call it as international only if it has the ability to expand or stretch its influence beyond the international boundaries, or beyond the national boundaries, or beyond the geographic boundaries. Then and only then we can say that yes, this particular journal is an international journal because the influence it has spread is really international. So the next question is, okay, now we have a definition. Do we have the parameters? Do we have the indicators, right set of indicators, which can measure the international aspect of the journal? As of now, no. But in this PhD problem, that's what we are going to solve. Okay, so what am I saying? Again, am I saying that there is no existing matrix as of now which can measure the internationality of the score? Yeah, there are matrices. For example, impact factor, a very, very popularly used matrix. Suppose if I want to know whether a particular journal is good or bad, I will straight away look at the impact factor. But then again, there are many stories. Most of the time, the journal will be involved in some fake practices, and they will arbitrarily shoot their impact factor because nobody knows how to compute impact factor, I mean, in general. But if you really see, an impact factor is nothing but the computation of the citations which a journal has received in past 2 years divided by the total number of articles. So directly or indirectly, these matrices and these indicators are completely relying on the citations which a particular journal has achieved. Impact factor, H index, SJR score, site score, and many more, sites per doc, many, many more. All of them are directly or indirectly using the number of citations which a particular journal has got. So till now, these citations are not talking about or not touching the international aspect, capturing the international aspect of a particular journal. So are there any efforts made? Yes, there are. And we'll talk about that now. And we'll also try to see if there is a growth pattern, which is apparent in the growth of a particular journal. So previous definitions and previous work on the internationality was pretty much dominated by the work done by Buella-Castle. He wrote a couple of papers and he actually investigated internationality of the journals, right? He also gave a neurofuzzy modeling approach to capture internationality. He did that, okay, some 15 years back. And interestingly, the factors that they have identified to know whether a particular journal is international or not, they are like that. So what these people say is, and in fact, most of the people, when we ask them, how will you say a journal is international? This is what comes into our mind. So they say that a journal can be international if it has an international editorial board. Very promising answer. If the publication language is English, okay. If they are included in citational databases, international databases like Scopus, Web of Science, SJR, and whatnot. If the impact factor is high, we can say, okay, this is debatable again, because we know how we compute impact factor. Impact factor is nothing but the number of citations a particular journal receives in the previous 2 years divided by the total number of articles. So this is only capturing the citations which a journal has received. It is not even worrying about where the citations are coming from. It's not touching the international aspect of a journal. So if somebody says that if the impact factor is high, we say it is international. No, we don't agree. Author's country, okay. And some people also say that international word included in the name of the journal says that the journal is international. For example, International Journal of Computer Trends and Technology and whatnot. Right. So what is the problem? What is the problem if we do not know whether a particular journal is international or not? Problems basically are that there is no clear definition, there is no clear mentioning of how do we define internationality. There is no clear definition. Okay, and we also know that the number of journals are increasing at astronomical rate. Number of articles which are being published are also increasing at astronomical rate. There is also a practice which is known as predatory publishing. That has also exploded in the recent years. So what happens in predatory publishing? Okay, so there is a journal. What a journal does is, unethically, it asks people to submit. It asks the researchers and the authors to submit an article. Okay, ask for a publication fee in the name of article processing fee, and then promises to get the article published without any editorial service, without any peer review. Okay, on the other side, we have the authors who are always in a haste to publish, because ultimately they also need to show their work to the institution, to the organization, to the upper managements, to show that they are doing some work. So they are also in a hurry, kind of a win-win situation. But there is a big question mark here, because if this predatory publishing is increased to a very high level, then what will happen is, without authentic peer review, without checking the authenticity of the article will be published, and scientific community can receive a setback, because articles, without being checked properly, they are getting published. So this needs to be stopped. These are some of the problems which are there in the existing system, and hence it becomes important to clearly define and quantify and model it, so that there is no confusion. Okay, now is the time to talk about how do we define internationality. So according to us, the internationality, a journal can be called international if it has the capacity to expand its influence beyond the geographic boundaries of the country or of the region. We have defined internationality as, internationality for journal is a characterization of all the international aspect of a journal. And what are these international aspects? One is the quality of publication has to be very good. Second aspect says that the international span of the subscribing readers and authors and reviewers has to be vast. We also want to investigate a journal for the internationality by checking the geographic source of the citations which a particular journal is receiving. Because if the citations are coming from beyond the boundaries of the journal and beyond the boundaries of the country where the journal is actually originated, it means it has spread influence. It means it has gained a lot of reputation, and hence it deserves to be called as an international. So arguing on the same line, it pretty much says that we should be able to gauge the impact it is trying to spread across the nations. So we have given a definition, we have identified the parameters, but luckily when we were trying to investigate these, none of the parameters, none of the indicators today are here to evaluate, which can evaluate a journal on the basis of these aspects, right? In a nutshell, in a very quick way, how did we do the score computation? Because now we are going to dive into the details of how we computed JIS and how we computed the JIMI, which is Journal Internationality Modeling Index. So what did we do? We computed two matrices, journal influence score. So journal influence score is basically capturing the influence of a journal. We also computed, we also proposed a new metric with the name Journal Internationality Modeling Index. So this is the metric which is modeling the internationality. And what do we say? We say the final international score of a journal is a convex combination of JIS and JIMI. So alpha is one parameter. Value of alpha can lie between 0 and 1. And alpha pretty much decides the weightage we want to give to the two parameters, to the two metrics, which is JIS and JIMI. Okay, so this is again the big picture of what we have tried to do. So let's have a bottom-up approach. So what do we see? We see an internationality score, which is a convex combination of JIS and JIMI. And on the left side of the diagram, we see how we have computed JIS. On the right side of the diagram, we have shown how we have computed JIMI. So basically, the left side where we have computed JIMI, where we have computed JIS, Basically, it's a very lightweight approach. It doesn't require much database to be stored. We have taken the data from SciMago journal and country ranking portals. We started with 13 parameters. And those 13 parameters, those 13 indicators are basically describing the journals which are indexed in Scopus. Right? We perform the dimensionality reduction. Why do we do that? Because obviously 13 parameters, and if the number of journals are really huge, the computation will be really high, and then we need to shrink the parameters from 13 to some lower number. What did we do? We performed the statistical hypothesis and testing, and alongside we also computed the correlation coefficient between the parameters and the final score, and we reduced the parameters from 13 to 5, computed, then we applied multiple linear regression and computed JIS. On the right hand side, what did we do? We identified the parameters, we scraped the web, computed those parameters, and fed those parameters to our model, which we are calling it as Cobb-Douglas production model, and computed the value of JIMI, and the convex combination of both the scores gave us the final score. Okay, let's go further in details now. So the first thing which I'm covering right now is the computation of JIS. We have taken the database from Scopus, and for this
Archana, sorry to interrupt. There is a text bar that is appearing at the bottom of your slides, which says meetgoogle.com is sharing your screen.
Yeah, got it. Okay. Okay, thank you. Even I was looking for a way how to remove that. Thank you very much. Okay, so the journals which we took for our study is close to 1,000 journals, and they were picked up mainly from the domain of computer science and engineering. And as I said, we picked up 13 parameters, and these 13 parameters are mentioned here. So we picked up H-index for the journals, total docs for the current year and past 3 years, total citations, reference per doc, cites per doc for 2 years, 3 years, 4 years, and uncited documents and cited documents along with the international collaboration. And we also recorded their SJR scores. Now, what these SJR scores are, basically in SciMago journal and country ranking portal, they also pretty much give a score to every journal, okay, which is indexed in SJR. And this and how do they compute this score? They basically use a Google page ranking algorithm in the background, which compiles a large amount of citational information of these journals and give them a score. So we have also recorded these scores just to see how good or how bad our model was. So going further, this is pretty much the block diagram of what we did. We picked up the journal information. The parameters, journal parameters were for the 2 year 2011-2012, and we performed the significance test and correlation coefficient. What did we do? We selected a parameter, and we performed the significance test. We decide we measured the null hypothesis, alternate hypothesis, and then we computed the p-value, and then we checked the p-value if it is greater than 0.05. So what does that pretty much means? That it is time to accept the null hypothesis. Okay, what is the null hypothesis that we usually set? We basically set it in this way, that the parameter has no impact on the SJR score. So if we are accepting the null hypothesis, it's time to remove that particular parameter, and we doubly checked it. Okay, so how did we check it? Once again, we computed the correlation coefficient of the parameter and the SJR score. So this basically checks the strength of the relationship between the parameter and the SJR score. So the strength is weak, which means the score is less than 0.04. It's time to remove the parameter, otherwise have it. Repeated this process, and when we repeated all this process for all the 13 parameters, we got final 5 parameters, 5 crucial parameters on which we applied multiple linear regression, found the regression line, found the intercept, found the regression coefficients, and then we were able to get the journal influence score for all these journals. This is pretty much the significance test, and correlation coefficient is something which we are already aware of. And then this is in the pipeline. Sometime after when we started working with the 13 parameters were reduced to 11 because we removed certain parameters. Then they were removed. Then there were again 9 parameters which we were able to see, and these are the 9 parameters in one glance which I see with the p-value and the correlation coefficient. So what we see here is parameters like reference per doc has p-value greater than 0.05, and the correlation shows that has a weak correlation. Likewise, citable docs and total docs also show these parameters were removed, and these are the final 5 parameters along the p-value and correlation coefficient. Then what? So once we have got the parameters, it was time to find the multiple linear regression equation for these parameters along with the SGR score, and we found the regression coefficients and intercepts, and our final final equation, which could compute the JIS score for a particular journal, looked something like this. We have the intercept, we have the regression coefficients as well. So alongside, we also created a toolkit which in the background was using this particular equation. It was using this equation, and if we put in the values of these journals, we get a score of this kind. So this was an interface which was created behind the scenes. The interface was using this particular equation. Okay. So as a result of this, the publication which we received was this paper was basically accepted in Colnet Journal of Scientometrics and Information Management. It was published by Taylor and Francis. Taylor and Francis is the publisher. We got it published. So, and this is in Web of Science, I think Q2. Okay, so we saw how to compute journal influence score using the concept of significance test and correlation coefficient along with multiple linear regression. Now is the time to see how can we compute the second metric, which is Journal Internationality Modeling Index, and this is the metric, this is the indicator which is actually modeling the internationality of the journal. Right. So as we know, we have already said that internationality of a journal basically depends upon certain parameters. The parameters involve the quality of the publication. It also involves the evaluation of the span, the international span of the authors and the reviewers and the readers. It also involves investigation of the geographic source of the citations which a journal has received. Okay, and this goes without saying. Why are we investigating these particular parameters? Because we want to see how much impact a particular journal has made beyond the national boundaries. Okay, as a result of which, as I think I've already mentioned this, that till now, whatever parameters we had, those parameters were basically talking more or less about the influence which a journal has achieved. It's not talking about the internationality at all. So it was time to talk about new matrices, time to propose new matrices. So we as team proposed 4 parameters with the name ICR, International Collaboration Ratio, NLIQ, Non-Local Influence Quotient, OCQ, Other Citation Quotient, and SNP, Source Normalized Impact per Paper. Now, I will talk about these parameters, and then we'll come to talking about the model, and then we'll come to talking about the scores, and then we will talk about the analysis. Right. So what are the definition of these parameters? NLIQ basically checks how many citations the journal has received beyond the boundary of the journal where it has published. What does that mean? So in a simple word, if I have to say, then assume that for a particular year, let's say 2020, a journal X has received 1,000 citations. Out of these 1,000 citations, how many citations were originating from a different journal? So let's say there are close to 800 citations which are coming from the articles published in different journals. Right. This basically checks that the journal has gained visibility outside the boundaries. Correct? So this pretty much says that the NLIQ of the journal is 0.8. Okay. Next metric is OCQ, that is Other Citation Quotient. Self-citation, if I want to talk about, is an author. Say, suppose I'm an author, I can always cite my own work, which is pretty much known as self-citation. But if I do it extensively without any context, then I am trying to do this to artificially trying to boost my citation count, which is not a nice thing to for any author or for any researcher for that matter. So OCQ is a measure which checks whether the journal is practicing how to demotivate self-citation by the authors. Okay, so to compute OCQ, what it pretty much does is it examines the self-citation received by a particular journal. Okay, and a self-citation is divided by total citation, and 1 minus this part, self-citation divided by total citation, gives me OCQ. Okay, so the next important parameter about a particular journal is a SNP. So what is a SNP? SNP is source normalized impact per paper. Okay, it requires a background. So assume that there is a domain. Let's assume that the domain is applied mathematics, or let's say the domain is industrial mathematics, astroinformatics. These are the domains where the number of researchers working, the number of authors who are publishing is less, is comparatively less. It's not very less, it's comparatively less. Okay, so when the authors are working less, number of articles published are less, and hence the exchange of citation is also less, and hence the journal who's publishing in these particular domains will receive low impact factor. Okay, so a journal which is basically a reputed journal but has a low impact factor because of the low activity of publication or research happening in the domain cannot be compared with a journal which is publishing, on the other hand, in a very highly active domain. For example, nanotechnology, for example, bioinformatics or anything. The number of publications are more, the number of citations exchanges between the articles are more, and hence as a result, the journals who are publishing in this hyperactive domain, they are also receiving a lot of citation, as a result of which the impact factor is high. Okay, the influence, the reputation of both kind of journal is high though, but the impact factors are low. One has low, the other one is very high, right? So we feel it is not a good idea to compare journals who are publishing in different domains. That is where the source normalized impact per paper comes into picture. So what it does is it basically computes the citational potential of all of these domains, right? And once the citational potential of these domains are computed, what it basically does is it divides the total number of citation by the citation potential, and hence normalizes everybody. So now I'm in a capacity using SNP. I'm in a capacity to compare the SNP of one journal and another journal, even though they are publishing in different domains. That's a very interesting indicator if it is, and it's very important also, because now when we are moving towards building the internationality model of the journal, we need to be careful, because journals could be from different domain. If we do not include this, then probably we are not doing justice with the domains where the citation potential is less, where the activity is less. Automatically, because of the parameters, they will be low in internationality score, which could be misleading. Okay, so what is ICR? So if we remember really, taking a look at the internationality definition, I'll just take a look at the time. Okay, taking a look at the definition of the internationality which we have given, we want to examine the span of the authors, particularly the authors, and that is where ICR comes into picture. It basically checks how many authors are from the country different from the country where the journal is publishing. So how do we pretty much do it? Let's assume that there is an article published by a particular journal X, and the article has 5 authors. Now, all these 5 authors, if they are from different countries, from the country of this particular journal, the ICR will be very high. Okay. Which means that if there are 4 authors who are from different country and one author is from the same country, the score will be more in comparison to the score which will be computing for the authors, where all the authors are from the same country. Right. Talking about these matrices, so we are now in a position to quantify the internationality of the journals now. So having said that, coming up with these parameters, how are we going to compute these parameters? We do not have any repository as of now. So we had to build the complete repository in the database, into the database by performing web scraping. So we have written Python algorithms. We have written Python scripts using Beautiful Soup parser, and we have parsed the parameters, every information related to the journal. So journals were identified, close to 1,000 journals, their country information, their names, the articles which they have published, the authors who have contributed their manuscript into those journals, their affiliations, and the citational information. All of this information, along with many more. So these informations were extracted through web scraping, and the complete repository was built. Right. So after this exercise, once we were ready with the data, this is pretty much the big picture of the complete process. We did the scraping. Web scraping was done using Google Scholar and A-Miner also. And the data was extracted, and then it was saved in the repository, and then it was fed to the Cobb-Douglas function. We computed JIMI. Right. Time to talk about Cobb-Douglas production function. So basically what happens is...
Since you've covered a fair bit, you can just pause a little bit if there are any questions. I don't see any in the chat as yet, but yeah, any questions? You can just...
Good afternoon.
Yeah, go ahead, please.
Yeah, so I have one question.
Hello. Yeah, please.
Good afternoon, Archana.
Good afternoon, sir.
Good afternoon. You said this self-citation, you will, the people who are doing the self-citation, you did, based on the context, you are going to decide the score.
Yes.
So how do you find the context here?
Yeah, correct. So it will be actually a difficult exercise because it will require a lot of intensive information about, because contextual citation, searching for contextual citation, and identifying and saying that, okay, this is a worth self-citation and this is a self-citation not worthy of being considered. Quite an extensive exercise. So basically what we did is, we did not go into the depth of analyzing the contextual citation. What we were trying to do with this particular metric, which said OCQ, which is other citation quotient, what we were trying to do is, we identified the citations which were coming under the category of self-citations, and we just removed it. And if we are doing it genuinely for all the journals, then I don't think this is going to make much difference. So essentially, it is an extensive exercise if we compute the contextual citation of every self-citation that has happened. It's a very rigorous exercise. This could be done in future if we want to take it further down the line. But at this point of time, we were only interested in uniformly removing all those citations which were coming in self-citation category. That's it.
Okay, thank you. Thank you.
Yeah, sure. I think I can move on. So basically, time to talk about the model. Very interesting, a very powerful model given by mathematician and economist with the name Charles Cobb and Paul Douglas in the year 1928. While they were working in the field of economics, they wanted to establish a relationship between the production input factors and the output production factor. So in order to do that, they gave a formula, they gave an equation which looks something like this. So y is equal to k, the product of xi to the power fi. So where xi are the input factors, right? And y is the production output. alpha is the elasticity parameter and K is a constant. Right. So with this particular formula, this particular equation looks pretty simple, but it has really wonderful analytical properties, which we will be taking a look at going further. Right. So one of the important property which we also used apparently in our internationality model is the fact that it can exhibit the property of concavity. Right. So let's dive into it a little bit more. So when I say I have a function fx which is concave in nature, when do I say a function is concave? When it has all the points under the graph, which I'm representing as a shaded pink shade, when all the points under the graph are convex. So what is it that that is very appealing here is the largest value, the largest score, which we can use as the largest international score, is what we are getting it over here. So with this property, which shows that the function is concave in nature, we have to use this property to identify the largest possible international score, given that the fact that it guarantees a maxima. Right, but just by the visual inspection, we can never say the concavity is achieved or not. So what we essentially do, it's a standard process. We compute the Hessian matrix of the function, which we want to check whether it is concave or not. And what is Hessian matrix? Basically, it's a second order partial derivation of the function. And after computing the Hessian matrix, we check whether the first order principal minors or second order principal minors are positive or negative. If the function is negative semi-definite, under the conditions that first order principal minors are less than 0 and second order principal minor are greater than 0, we say that the function is concave. And this is what we pretty much did. So that's the Cobb-Douglas function using just the two input parameters that we have used, along with the exponents alpha and beta, and we computed the Hessian matrix. We checked the first order principal minors m1, m1 dash, second order principal minor m2 dash. Now we wanted to identify under what conditions the function will behave like a concave function. Okay, time to take a time to explore a little bit about more about the analytical properties of this particular function. So Cobb-Douglas function basically exhibits constant return to scale, increasing return to scale, and decreasing return to scale. Okay, what are they? Very quickly, if I have to tell them, then it's like this. For the constant return to scale, I have the exponents, or I have the elasticity coefficients alpha plus beta is equal to 1. And not just that, if I double the input parameters, the output parameters are also doubled, which means to say the output and input changes proportionately. Right. So talking about the increasing returns to scale, this is true when the exponents alpha plus beta is greater than 1. Okay. And what it means is if I double the input parameters, the output parameters are more than doubled. So the change between an input output is disproportionate. So conversely, for decreasing returns to scale, the condition is alpha plus beta should be less than 0. And what it says is if I double the parameters, input parameters, the output parameters are less than double. Right. So if I want to investigate whether the Cobb-Douglas function is concave under the decreasing and constant return to scale, which signifies alpha plus beta is less than or equal to 1, this is true. If this is true, then my first order principal minor is less than 0. Second order principal minor is greater than 0. And I can say that my Cobb-Douglas production function is concave under the decreasing and constant return to scale. Okay, time to take a look at the visualization of this. So this is a plot, kind of a surface plot for the Cobb-Douglas production function. And if you really see, I have alpha in one axis and beta on another axis, which we varied from 0 to 1 and 0 to 1. Right. And what we see, if I fix the input factors, which means to say if I start talking in terms of the internationality now, and if I want to use this for computing the international score, then what it pretty much says is for one particular journal, if I freeze the input factors as the same value, and if I keep changing the value of alpha and beta, then for some value of alpha and beta, I see the largest value of the function, which I can label as the largest international t-score. Right, and that is the beauty of this particular model, and that is the reason the model becomes very interesting and very flexible and very powerful as well. So what we did, we computed all the 4 parameters, that is the citation quotient, international collaboration ratio, SNP, and non-local influence quotient, and we fed these values, keeping the value of k as 1, and alpha 1, alpha 2, alpha 3, alpha 4. The values were computed using the fminconf function in the MATLAB, and then we were able to see the score. Right, so this is just a glance of how we computed, how we got the values. I mean, for all the values, for all the journals, not possible. So I've taken a very small, quick screenshot of the values which we got for NLIQ, ICR, OCQ, and SNP. And we got the scores also. So time to talk about the analysis of what we got as the scores, and it will be actually a good exercise if you can compare with the already existing parameters. So we computed the internationality, and we ranked the journals also. So this is just the top 8-9 journals which I'm showing here right now. Why is the internationality score which I have got, and we also computed the impact factor. We also captured their impact factor, normalized them. We normalized these impact factor. Okay, then we developed 2 ranking. One is the ranking on the basis of the scores which we got, and another one, another ranking was on the basis of the impact factor. And we got something very, very interesting. So what I'm showing you right now is just a couple of 2-3 examples to understand and do the analysis. So most of the time, the ranking were almost same. The ranking were almost same, except for some time. Oops, I'm sorry. Except for some journals. So I want to highlight here this IEEE intelligent system. Our ranking says that it's at rank number 5, which means to say it's really, really international. But in terms of impact factor, the impact factor says that the ranking is low, which means to say the influence of the journal might be low. Not very low though, but influence of the journal might be low. But when it comes to measuring the international aspect, it's at a very high position. Another interesting example would be taking a look at the computer networks. The site score rank, or the number of this is decent, is pretty decent. But when we take a look at the ranking developed using impact factor, it is at 17th rank. Not a very bad position per se, but in comparison to the internationality ranking it has got, there is a clash. So what is the takeaway of this exercise? So the journals which might be considered influential, because we are taking a look at the matrices and the indicators like impact factor or H index or SNP or site score. So they may be less influenced. But when it comes to measuring the internationality of these journals, they are at a pretty decent level. There's one more journal, like IEEE transactions on network of service management. I think that's what it is. Network and service management. I think it got out of the slide. The important thing about this particular journal is that it is ranking 2 in the rank of the impact factor, which means to say that the journal is very, very reputed. But in terms of internationality, its rank is pretty low. So I think with that analysis, and of course this was the publication, which was published in the journal with the name Scientometrics. The publisher is Springer. It is Q1 journal. Right. So having said that, we have developed a model, we have explored a model which has some very powerful properties, analytical properties and all. The second phase of the work says that, is it okay if we use this model to take it further and to build some theoretical work wherein we are able to directly or indirectly use this particular model and extract the properties. So are we in a position to do that is the next question which we had in our mind. So we started exploring, and as a consequence of this, we proposed kernel functions, activation functions, and some frameworks, which I'm going to talk about. I will not go into the details because a part of work is still under progress. And some of the one work is two works are actually published, which I can share as much as possible, but some of it is still not done yet, not completed, almost in the final stages. Right. So talking about this, we know how SVM work, support vector machine, a very popular machine learning tool, wherein if we have our data, if we have data which is linearly separable. So by linearly separable, I mean to say I can find the best line in 2 dimension or a hyperplane in multiple dimension, a best hyperplane or optimal hyperplane which can divide my classes into the 2 separate categories. Right. So as long as the data is linearly separable, no problem. If the data is non-linearly separable, which means we are not in a position to find a single line, an optimal hyperplane, which can do the classification of dividing the classes, then kernel trick comes into rescue. We are aware of the kernel trick. What do? We already have some already existing kernel functions with us, polynomial kernel, RBF, sigmoid, and many more. What we essentially do is, all the data points, we apply kernel function to all these data points and essentially transform them into a high dimensional space. Right. So when we transform them into a higher dimensional space, so this picture will give an even better idea. So what do I see here in these points represented as purple and yellow line? That this basically are non-linearly separable data. I cannot find a single line or a hyperplane which can classify the 2 classes. But after the application of kernel, after the application of kernel function, I am transforming these points into a higher dimensional space, wherein I am now in a capacity to find the optimal hyperplane, which can classify the 2 classes. That is the essence of kernel trick, and hence we decided to define a kernel function with the name Cobb-Douglas because it has the structural property of more or less like a Cobb-Douglas. So we define it in this way. So if x1, x2 are the 2 data points, we define Cobb-Douglas kernel function as k0 plus k, x1, x2 dot product to the power alpha, right? Where alpha is the exponent, it's the exponent, and k0 and k1 are the constants. So not every function can be used as a kernel function. There are some conditions, very well defined conditions, which needs to be satisfied, and those conditions are basically known as Mercer conditions. So the first condition says that the kernel function has to be symmetric. And what do I mean by that? So basically it's like showing kxy is equal to kyx, which is pretty simple to show, and we have shown it also. Kxy has to be continuous, which it really is. And the third important property of this Mercer theorem is, it says that the kernel has to be positive semi-definite. So what we pretty much do is, we define an integral operator with the name tk, okay, and we also we define it for the symmetric kernel k and apply it on a function g. G is square integrable function. So if we define it in this way, t gx, it pretty much means the integration of k kxy multiplied by gy and dy. Okay, so according to the Mercer condition, if I can prove that the integral operator, which is represented in this way, okay, double integration of kxy gx gy dx dy, if it is greater than 0, it pretty much means that the function is positive definite. There is a lot of theory also behind this, which I'm not touching. It's just from the surface, which I'm trying to explain these things. So if I'm in a position to show that this integral operator, double integral operator over here is greater than 0, it pretty much means that the function is positive definite, and we can assume that the third condition is also satisfied. So what did I do? What did we do? We kept the value of the kernel over here, k0 plus k, k0 plus kappa, x1 plus x to the power alpha, multiplied by gx gy dx dy, applied binomial theorem to this. So when I applied the binomial theorem and expanded this And after multiple steps, after the application of binomial theorem, I got an equation which looks something like this. Right. So this is the complete equation, actually. Pretty long. This is the complete equation. So if I assume that K0 is greater than 0 and the kappa coefficient is also greater than 0, then these are the factorial terms which can never be negative. And this term is a square, actually. This is the property of linear operator here. So this is a square anyway. So this whole term we were able to show is positive, and hence we were able to show that this guy over here, the value of this guy is greater than 0, and we were able to prove the Marshall theorem for this function as well. Right. So it was time to take a look at the theoretical investigation was done. Time to take a look at the data sets on different data sets. So we have used a data set which has 15 classes. Basically, it's a wheelchair data set. It has 22 features, 22 dimensions, and it has 15 classes. So in order to visually inspect the effect of the Cobb-Douglas kernel, what we did was we picked up two classes, class 6 and class 7, as you can see here. Picked up two classes and we picked up two features, just two features, right? We have we produced a scatter plot of this. So we can see there are two classes over here, two points represented by different colors. So there are two classes. And after the application of the kernel, pretty much there are 73 points. So when I applied the kernel, when we applied the kernel onto this, I was able to see a separating hyperplane and the margins. These dotted lines are the margins. And there are some circles in the red, which were the support vectors. So for these 73 points, we were able to see 8 support vectors, and the classification accuracy looked something like this. This is the confusion matrix. Classification accuracy showed us that we got 94% of 94% accuracy, 94.7 actually. So since the work is almost on the verge of completion, I am not in a position to show the complete details about it. Okay, right. So inspired from, again, the properties of Cobb-Douglas function, we were wondering if we can show this particular function as an activation function. Is it possible to do that? So let's take a look at this now. We know how neural network works. We have the inputs. This is pretty much a neuron, and basically a vanilla or a simple feedback neural network is something like this. We have neurons arranged in the form of layers, and they are connected to each other with weights, and we have gradient descent algorithm using which we propagate the error backwards. We optimize the weights, and then eventually over the period of time the neural network converges, and every neuron is equipped with an activation function, and we have a long list of activation function as of now, starting from sigmoid, tanh, hard tanh, ReLU, eReLU, sReLU, leaky ReLU, swish, mish, and now we also have 2 more activation functions we want to talk about right now. So with these activation functions in line, are we in a position to define a new activation function using Cobb-Douglas structure? Let's see. So what did we do? We defined an activation function with the name Sahabora activation function. The function looks something like this. We have y is equal to 1 over 1 plus k x to the power alpha, 1 minus x to the power 1 minus alpha. And then we see any function. Are we in a position to use any function as an activation function? Actually, there's a theory behind that. So the theory says that there is a theorem given by Cybenko with the name universal approximation theorem, which says that any network with a single hidden layer and some number of neurons, some finite number of neurons in the hidden layer can approximate any function, can approximate function to a very large level of accuracy. And the theorems are actually proved for sigmoid and ReLU. So we actually proved the theorem for SBAF also. We have actually proved it. It's there in the paper, maybe for details if somebody wants to take a look at it. And beyond this, we also observed the analytical properties of SBAF. So we wanted to examine whether there exists an optima for the function. So what did we do? We pretty much computed the derivative, equated it with 0. We saw it becomes 0 at x is equal to alpha. So is alpha x is equal to alpha the critical or the optimal point? To be able to find that, we computed the second order differential equation, which looks something like this. So this is the second order differential equation at x is equal to alpha. And for certain values of x and y lying between 0 and 1, this is greater than 0. Second order differential equation is greater than 0, which ensures that there is an optima. Right. So if you take a look at this surface plot, where x is the x lying between 0 and 1, and y is the alpha, z is the function, you can see an optima over here. We see an optima here. Right. So going further, we also wanted to see whether there exists a minima in SBAF. So what did we do? We pretty much plotted k and alpha. This x is alpha, and this is the SBAF function. So we varied the value of k between 0.9 and 0.98. And what we found was at the value of alpha is equal to 0.5, we see a minima. So basically these things are, we are trying to investigate the structural properties of SBAF and also the geometric properties or analytical properties of this particular function. We also wanted to see whether there exists a fixed point, a stable fixed point in SBAF. So in order to find the stable fixed point, we have plotted the first return maps for this function alpha, for this function SBAF, where we have kept the value of alpha as 0.5, and we have kept k larger than 0. Precisely these two values. So these are the plots which we get. This is the first return map. Okay, and the first return map shows a dot here and also a dot here, which confirms the presence of a stable fixed point. Right, and then we also investigated. For some reason, my slide is not moving. Okay, when we get here, so what we also did, we plotted the first return maps for SBAF for the same value of alpha, because we know there is an optima at alpha is equal to 0.5, and there's a minima actually. There's a minima at alpha is equal to 0.5. So we picked up few negative values of k, and we found that there exists no fixed point. So we have taken 5 negative values of k and plotted the first return maps, and we saw that there are no fixed point, which means to say that the function is more stable for the values of k being greater than 0 and alpha is equal to 0.5. Right. So time to talk about another activation function.
Can I come in here? Can you go back to that slide, please?
Yeah, sure.
That yeah. So I mean, just to give a little bit of perspective, because I can't really keep quiet. I mean, if you are familiar with the butterfly effect, so what really happens is, there is this theory that if a butterfly flaps its wing in Texas, so there might be a possibility of a storm in California. So what it really means is that, I mean, if your function, if it's not stable enough to an initial set of perturbations, so there is very low probability that it will ever stabilize even after multiple number of iterations. So that's what a fixed point is all about. So when Archana was showing you a fixed point, which is just a single dot, what it really means is that, after a certain number of iterations, of course, I mean, in a computing system, you got to, have an upper bound for the number of iterates that you could actually manage within a finite amount of time, right? So what it really means is, after a finite number of iterates, I mean, that point is not really moving. So you can see the striking difference between this picture and the picture in the next slide, okay, where you actually see that the trajectory is continuously moving, right? So what really we wanted to see is that, in neural networks, hyperparameter tuning is a common thing, right? Everybody does it, right? But I mean, as a practice, I mean, we should not really encourage hyperparameter tuning unless we have to, really, right? So since we knew that the activation function itself, universally approximates any nonlinear function, monotone or non-monotone, over a sufficiently, deep and wide neural network, what we also wanted to see is that for what values of the hyperparameters, right, this will hold good. So since we already knew one hyperparameter alpha, if you recall, the SBAF has two hyperparameters, right? One is alpha and the other one is k. So for one hyperparameter alpha, the function has a minima, and therefore, I mean, we could actually, it could settle down in a over sufficiently large number of iterates over a deep and wide network. It will settle down to a minima, okay, thereby giving us a sort of a minimum error. But at the same time, since there is another hyperparameter k, we really did not know what values of k to choose. K could be negative, k could be positive. So what we did was a set of experiments which Archana was showing. So for negative values of k, we did not really see the fixed point settling down at a particular trajectory, right? Yes. So, and then when we did for the positive values of k, we then saw the fixed point actually settling down. So for some specific values of positive values of k and for a specific value of alpha, we have a fixed point. And this also sits beautifully with the interpretation of the Cobb-Douglas production function. Because in a production function, if the constant k is negative, it actually means nothing in terms of a production. Because what it really says is that no matter how much capital and labor you are infusing into the system, your output is always negative. So you are always running at loss.
Yes.
So, however, we did not know this. I mean, our experimental findings turn out to be in sync, turn out to be consistent with what the economics theory tells us, right? But we had no way of knowing this until we had conducted these experiments. Yes. So sorry for being flippant, Archana. I just thought I could just come in and,
that was actually really helpful. It actually gave a perspective.
Go ahead. Yeah.
Yeah. Thank you. Yeah. So with this, let us also take a look at another activation function, which says it is a ReLU. It is approximating ReLU. So what is the problem with ReLU, that we have to come up with with a new activation function, which also has the structural properties of which looks like Cobb-Douglas model, like y is equal to a x to the power n. And so the problem with ReLU is wonderful. ReLU has shown very, very great accuracy in deep learning models and whatnot. Linear model doesn't suffer from vanishing gradient problem and whatnot. The thing is, ReLU is non-differentiable at x is equal to 0. Being non-differentiable at x is equal to 0 states that it doesn't have a derivative at x is equal to 0. We know that when we are talking about training a neural network, in the backward path, in the backward propagation, we compute the derivative of the activation function. We compute the gradient, if you really recall. Then we compute del E by del W. In order to compute del E by del W, we utilize the derivative of the activation function. So if the derivative of ReLU becomes 0 at some point, then the gradient becomes 0, which pretty much means there is no weight update, which means the network fails to learn. The network just cannot learn anything. Hence, it was important if we can come up with a new function which approximates ReLU, and hence the name a-ReLU, right? So what did we do? We wanted to basically have a function which is very close to ReLU. So in order to find that, find certain conditions under which a-ReLU will behave like ReLU, we convert it into an optimization problem where we are trying to minimize a x to the power n minus 1, subjected to the constraints a greater than 0, n greater than 1, and x lies between minus 10 and plus 10. And when we did the optimization, when we solved the optimization, we could see that at a lying between 0 and 1 and n lying between 1 and 2, this function behaves like ReLU. So visually, it will be even more appealing. So the function is like this. So blue line which you see is ReLU, and the red line you see is a-ReLU. It approximates ReLU for the value of x between 0 and 10, right? Beyond that, it works in its own way, right? So if the input is restricted here, this a-ReLU works like ReLU, and this is differentiable at x is equal to 0, right? So with these two functions, I think I've already covered the universal approximation theorem, not trying to prove anything at this point of time, but it pretty much says that any neural network with a single hidden layer and finite number of neurons in the hidden layer can approximate any function, which we have proved for SBAF. We actually did that. So with the theoretical understanding, it's also important to have a empirical analysis of the work which we have done. So what we have done is we have taken PHLEC dataset. Now to give a background of PHLEC dataset, it's an exoplanet catalog, publicly available catalog for exoplanets. So what are exoplanets? Exoplanets are the planets which are rotating outside our solar system, and the most important and a crucial problem associated these days is to find whether a particular exoplanet can be habitable or non-habitable. So we also capture, not we, I mean of course NASA. So they also capture a lot of features of these exoplanets, like their mass, their radius, the surface temperature, escape velocity, and many more features, right? So a catalog is built, and people and the researchers and the scientists are willing to know whether these exoplanets are habitable or non-habitable. Not going into the details of what is habitability and non-habitability, but just to give a brief idea, the habitable classes can be three. One is non-habitable, and second is habitable divided into mesoplanets and psychroplanets based on the surface temperature that they have. Right. So we have three classes in this particular catalog, which I have also shown over here. So this class is non-habitable, mesoplanet, and psychroplanet. And this catalog is extremely, it has unbalanced classes. Very large portions of these classes are, I think, close to 3,000 samples are non-habitable, whereas meso and psychro are around 40 or 60 or something like that. So highly imbalanced. So what did we do? We built a neural network, single hidden layer, applied multiple activation function. Here I'm showing just 2 or 3. I'm showing just 3. SBAF, ARELU, and Swish. We have actually also used MISH, ReLU, ARELU I have already shown here, and sigmoid. So those things are I'm not showing it here. It's a published paper, so one can anyway take a look at it anytime, any point of time. So Swish is something like this. We have Swish is equal to y is equal to x multiplied by sigmoid of x. So what we essentially did in this exercise is we had divided the data set into eight different cases. I am showing here only 7 because there was no space down there. So we collected different features. So in the first case, we have all the 45 features associated with the exoplanets. In the second case, we have 6 features. Then we have 44 features because we have removed one. The one feature which is removed is surface temperature, a very crucial parameter which can classify, habitability and habitable and non-habitable classes. And likewise, we kept on creating more and more cases. Right. So when we evaluated our activation functions, which are SBAF and ARELU, what we got is something like this. So for the case 2 and case 3, we could see 100% classification accuracy in spite of the fact that the classes were extremely unbalanced. Right. So SBAF also gave us some decent results, but we also observed that Swish just could not perform the classification for mesoplanet over here. See, if you really see, this is the accuracy. Precision and recall says it's 0. Precision and recall is 0 for more values also here. For the 7th case also, the precision and recall is 0 for the other 2 classes, that is meso and psychro. So the activation function actually could not even perform the classification for those classes, whereas SBAF and ARELU could do it. Right. So the publication involved in this particular is the evolution of novel activation function, which was published in European Physical Journal Special Topics, and some more things associated with SBAF. And then very quickly, I'll cover this up. What I'm trying to show here in this slide is the fact that SBAF, sigmoid, and ReLU, they are connected to each other in some way or the other. So if I if I keep the value of k as 1 and alpha is equal to 0, somehow I'm able to see that SBAF and sigmoid are same. Also perform some Taylor series expansion. Likewise, if I keep the value of k and alpha in SBAF as 1, both 1, I see this 1 over 1 plus x, and this is same as 1 minus ReLU. So SBAF is equal to 1 minus ReLU. So what I'm trying to show in this slide is that all of these activation functions are connected to each other in some way or the other. So this basically gives us a motivation to see from where these activation functions are arriving, or they are arising, or they are originating. Because till now, nobody has spoken about any of the framework which can show us what is the origin of all these activation function, whether it is SBAF or ARELU or sigmoid or ReLU or leaky ReLU, swish or mish or whatever. Right, to have the answers, in order to have the answer for this question, we have to begin from somewhere. So what we thought is, we wanted to explore the solution space of the ordinary differential equation. So we specifically have taken the case of harmonic oscillator, the damped harmonic oscillator, and this particular case can be represented in the form of a d square y by dx plus dx square plus b dy by dx plus cy is equal to 0. So we have taken this particular system, dynamical system, which is represented, which is described by second order ordinary differential equation given by this particular equation, right? For specifically chosen initial values, the function returns something back to me. I'll explore this, but before this, I also want to take an example of a oscillator, again as an oscillator, but this equation is a special case of the damped oscillator, right? This equation over here is a special case of the damped oscillator. This says x d square y by dx square plus 1 minus y dy by dx equal to 0. Specifically chosen initial conditions, keeping the value of k and n greater than 0, we were able to see a ReLU coming out in the solution space, right? So likewise, when we were investigating upon finding the general solutions of the ordinary differential equations, there were three cases: b square minus 4ac greater than 0, equal to 0, less than 0. And for all of these cases, we saw something. We saw that y is equal to the solution space. Y is equal to the solution space includes many activation functions. Okay. How? So if out of these, so we have picked up one example over here. Y is equal to f kx, k1x square, k2x cube, kn to the power n. So for one example, for one specific example, if I keep the value of k as 1, keep the value of k as 1, and keep all the other values as 0, we recover ReLU, y is equal to x. Likewise, keeping all the k values of k greater than 0 and all the other as 0, we also recover kxn. So coming back to this slide, one of the activation function would be knxn. So if I choose, at this point of time, let us assume that I am in a capacity to choose. I will take you to the example where I don't have to choose. Automatically the network will return us something. So at this point of time, assume that I can choose which k to be kept 0. So I keep k, k1, k2 all the way till kn 0. What I see in the solution space is a ReLU. Likewise, we were able to see 5 different activation functions arising from the solution space of the ordinary differential equation described by a damped oscillator. Right. So this is pretty much what we have done. So we have a damped harmonic oscillator represented or described in the form of ordinary differential equation in this way. When we solved it, we got these activation functions. Now what we want to do is we want to check it empirically. So when it comes to working on a neural network, what we pretty much do, we define the input layer, we define the output layer, we have the neurons in the hidden layer, and we have to pick up the most popular activation function, equip it in the neuron, and then we start the forward and the backward paths, and we try to see the accuracy, etc. But now in the solution space that we have 5 different activation functions, what are we trying to do is we plug in the data set, and we want the network to identify the activation function for itself on that particular specific data set. So I repeat, what I'm saying is I have the network, I have the data set, I also have 5 different activation functions lined up here. We will not plug in the activation function into the neuron. We want the network to learn the activation function by itself. Okay, so how did we do that? So this is some of the analysis which we got. We compared this, we have called this framework as DEFACT. DEFACT because we are saying activation functions arriving from the solution space of the differential equations. right? So we have called this framework as DFACT, and we have compared this all of these activation functions with the DFACT. Okay, and we could see decent accuracy. So what have we done is we have taken a lot of data sets with us: wine, a wheat seed, iris, hard data, card, banknote, breast cancer, ionosphere sonar, and we could see that DFACT was able to do better. So this is on the non-computer vision data set. On the computer vision data set also, it did well. We used MNIST, Fashion MNIST, CIFAR 10, CIFAR 100, Beans data set. And what we observed was this, that for each of these data set, the activation function which emerged from the 5 activation function were these. What are we trying to say in this is, at this learning rate and these many number of epochs, AReLU gave us the best accuracy with the minimal loss. Okay, so I think almost to the end. This is the work which is still in progress. This DFACT was this paper was published in is recently published in IJCNN, and this is all about building the ADACT. I am just going to touch this from the surface and not going into the detail because the work is still going on this. So what we are saying is, suppose if I define an activation function of this kind, gx is equal to k0 plus k1x plus k2x square, am I in a position, or are we in a position to learn these parameters through the data set? Can we allow the network to learn the parameter by itself? I think we can do it. How do we do it? We have done it in this way. So we have taken a 2 hidden layer neural network, right? And we have computed the forward pass, which is pretty simple. We also have computed the gradient. So the approach that we are using to compute, when we say we want the network to learn these parameters, then the network is learning it in pretty much the same way how the network learns the parameters weight and biases. So what happens in that case is, we compute the error gradient with respect to weight and biases, and then we use the delta learning rule to update these weights and update these biases. We are using the same principle here to update the values of K0, K1, and K2. So as you can see, not to go into the complete mathematics, not required, but as you can see, that dk2 and dk1 is what we have computed. We cannot compute dk0 because it becomes a constant term. This is how we have computed the values of dk1 and dk2, and we have used the same weight update rule which we are using in the updation of weights and biases in the network, and that's the result which we have got. So we were also able to see few more activation functions like shifted AReLU parabola, shifted ReLU, and SBAF approximate, and AReLU parabola. I think that's the work which is currently going on right now. I think I was not in a position to cover these works which are happening right now. These are some of the references. And if there are questions. Can I stop sharing the slide now?
Yeah, sure.
You can, Archana, you can just keep it handy, because if there's a question and you want to go back and forth, but I think, yeah, so you can keep the share on, but I think you have removed it. So yeah, just in case you want to quickly swap to some position. Some might be able to answer just like that, but generally it's easier to show in the slide.
Okay, are there questions from the audience?
Yeah, just for the sake of completion, I want to ask one question, and that is, the ReLU activation function comes from a certain kind of a finite element modeling applied to an approximation scheme. So I was wondering if there's been any thought or consideration of doing a comparison or trying to form an interpretation with kind of that in mind. Yeah, that's my next question.
Suryo. Yeah, Suryo. Yeah, it's a nice question. Yes, you are right. Even not only ReLU. I mean, if you really think of sigmoid, right, it really came from the step function, right? So the idea is this: when you think of it, that which is when that's the one when Archana was referring to the dynamical system, right? So in many of the dynamical systems, Like for example, we took a very simple dynamical system, which is a damped harmonic oscillator. If we go to a more complex dynamical system like the Euler Lagrange equation, there, I mean, from the parameters itself, I mean, we could actually, for many of these equations, we do not have the exact analytical closed form solutions like the one we have here, right? So therefore, there we can definitely use a variant of the finite element method. In fact, if you go back to how we formulated the ReLU to begin with, it was basically an approximation with ReLU. So what we did was we took ReLU and then we took the form of ReLU, and what we did is a least square computation between the two functions, right?
Oh, I
and
see.
so
I see. Okay.
exactly, that's exactly how it was done. So this was like a least square approximation, right? So you can easily, take it and plug it into a dynamical system and see where the motivation comes from. In fact, that's a very good idea. I mean, to begin with, I mean, just from an exploration point of view, an excellent question. And although we haven't explicitly done it the way you want it, right? But we are, I mean, in similar directions. Yes. Yes.
Yeah, so this is Anand. I mean, I'm not sure if I understood the full depth of Suryoday's question, but to an extent, right, in the this DeFact paper, you have kind of done that, right, or at least compared to the state of that, because ReLU by itself, it got adopted more as an engineering fix, a very good one, but more as an engineering fix to deal with the vanishing gradient.
Absolutely.
Maybe there are works, at least I'm not really that aware of a huge body of work where they sort of did something similar to what you did, where you know from the theoretical perspective, where you have a fairly simple differential equation, and as a family of solutions of this, interestingly, lot of commonly used activation functions pop out. So to that extent, what Suryoday was alluding to, I think, has been covered. But beyond that, of course, again, there are a lot more things.
Right, right. I mean, to specifically answer Suryo's question, I mean, we really haven't answered that in this particular work, Anand. I mean, it would be interesting to see whether you can build a ReLU from ReLU using a finite element approximation, which is what he was probably asking.
Yeah,
right?
it's broadly in that direction because yeah, so with the finite element basis and stuff, right? I mean, I'm not like very explicitly using the right jargon, but the finite element basis is like very simple but yet an elegant interpretation of what really you can accomplish in a theoretical sense.
Correct.
So I am just like, because we've gone into comparing all of these things, I was just like, it's just a little bit of food for thought. I know that it's not explicitly being done, right? But it's just a little bit of food for thought, that is there an interpretation or a cross interpretation between the two, like
there could be,
transposing it into
In fact, I can see the insight of your question. So I mean, I can see it, but we haven't explicitly done it,
right.
Okay.
Right.
So
my bias comes from the fact that I did an attempt at understanding to some extent to a working knowledge of deep learning, and after a while I gave up. So basically, I mean, it's building a monster and then the next big monster and applying on the next big data set, and everything has a shelf life of 2-3 months. So I basically gave up. So things like what Snehanshu has been working on in collaboration with Archana, Kakoli, and all these are still interesting, because I at least get the gist of it. So I was sold on just this idea of kind of a differential equation being like a generator in a sense of various activation functions. So I don't think I have the capacity but I was pretty much sold on that. I haven't thought beyond that at all.
Yeah, fortunately, Anand, the referees were also sold on that, so the paper went through. you know, otherwise, I mean, most of my work has just theoretical value, not much. you know. Anyway, any other question? I think the external examiner is keeping quiet, so maybe she's ready to throw some bombshells at the candidate.
No, no, no,
Hopefully not,
no.
but
Let the audience ask the question first, and then maybe finally
Okay,
I
okay.
can ask.
Okay, audience, if you could ask few questions. Um, you can also get back to us. I mean, and I think most of Archana's code is all published on
GitHub.
GitHub as well.
Yeah, everything is there on GitHub.
I just wanted to add one small note, which is that, I mean, when the thesis was started, I mean, under the supervision of Anand, so our initial plan was to stick to, do a large scale data analysis of the cytometric indicators and come up with some models, right? And then at the beginning of second year end of second year or beginning of third year, I don't exactly recall, we tried to start classifying the journals into international and national, right? In fact, I think Sriprana and I has a paper also on that, right? I mean, which is a granularity of internationality. But there, the quality of data was so bad. But then a spart of ideas came through, and then we thought, okay, since we do not have enough good quality data in the domain of cytometrics, let's develop some of the machine learning and deep learning theory and apply it to some other areas. So that spun off to astronomy, that spun off to wheelchair data, that spun off to some other cyber physical systems data also, right? Which my former student Suryodaya will like, because he is now working on cyber physical systems, right? And so, and he constantly disparages the machine learning community and people like me. So, I mean, anyway,
Yes,
at any
100%.
at
100%.
yes, of course. So at any rate, so that's why. So those of you who may be finding it difficult to connect how the modeling suddenly becomes an exercise in machine learning, for those, my feedback is the following: that using and developing machine learning theory was not what we planned, but it just came along because of certain difficult and complex problems in the cytometric data that we encountered, and we thought that we should develop some theory at least. Okay, so that's the connection between phase 1 and phase 2. Okay, I mean, if the audience do not have any other questions, I may now turn over to the esteemed external examiner.
Yeah, so Archana, very nice presentation, and yeah, it's a phase one, phase two. There are two parts of your thesis, and you very nicely explain both the parts. And there are, initially this internationality, so how you are measuring the internationality of a journal, and then some kernel functions, and also some activation functions, and the mathematics behind them. So yeah, so it is very nicely explained, and I think it's already, I was checking the referees comments, so all the referees have commented that it is an excellent thesis. So yeah, so it's heartiest congratulations that you did such a good amount of work. So I just have few queries, very
The
minor
credit
queries.
actually, sure. The credit actually goes to the supervisors. I mean, we are just understanding and executing it. So actually, it is most of the work is by Dr. Saha. So he keeps
Well,
inspiring and motivating. So
well,
actually, credit goes to him.
you are going to pass the examination anyway, Archana, so you don't really have to.
yeah, no,
No. I'm scared.
I think
Yeah.
everybody knows, but just to be sort of complete, yeah, of course, completely second Archana's point, especially I mean, I don't know if I was much help even early phase, but especially after I moved to bits, Snehanshu, helped a lot. And Archana, now I think you see the value of Snehanshu nagging you, nudging you, prodding you, and forcing you to do work in spite of, I don't know, the amount, the clerical work which was anyway there as part of your job. Right? In addition to that, you were forced to do it, but thankfully it all cumulative.
Actually, I'll add here because it was more interesting.
Mhm.
I really find it very, very interesting to solve these kind of problems, and very, very interesting in approach. So it was very interesting to work.
Yes,
Yeah,
yes, that's true.
please
No,
go.
Okay, but
as a
no,
part-time PhD, having 13 publications and that two in Q1, Q2, it's remarkable. Like it's very difficult. Like we are guiding so many full-time PhD students as well, and they are finding it difficult to publish 4 or 5 papers. And being a
that is
part-time
that is
student,
that is something that you should never believe. Archana, Sripana publishes 60, 70 papers a year.
yes, yes,
So
I can
I mean,
understand that. Yeah, yeah.
absolutely don't. I don't believe a word that she
I won't.
says. Okay.
I won't.
no, no, no. Seriously, as a part-time student, Archana is having her own responsibilities, yeah, in the institute, but still she managed to publish 13 papers that, and also the several conference publications. That is really very good. So I just have few queries, very minor queries, Archana. So you mentioned that in the SNIP, when you were calculating the SNIP score, you I think gathered information from DBLP and the Google Scholar.
Yes, we
Is
have
this
taken it from Google Scholar and A minor. Yeah.
A minor? Yes, yes, yes. So my question is that why not DBLP? Why did you not consider DBLP?
Uh, Actually, I think most part of the scraping gave us the results from Google Scholar. So I think beyond this, there is no other reason. I don't think there is another reason for that,
There was one
because the
reason. There is one reason, Archana, and the reason, Suparna, is DPLP creates a lot of problems when you send your scripts onto their page.
Mm-hmm.
Okay, so there's like one scrape a day, and then they will block you for 3 days.
Okay.
So that's one of the problem. And also, I mean, DPLP only gives you a certain set of journals and conferences, right? I mean, some computer science interdisciplinary journals, they do not even feature in their database. That's another problem with DPLP.
Okay. Okay.
Right. And
Yes.
A minor was easier for us because A minor, a lot of the information was already available on A minor. Because A minor themselves, they employ the beautiful soup parser, and they keep updating their database. And so that was easier for us to begin with.
Okay. And another question is that Archana, when you were just crawling the data, did you face the problem of entity disambiguation? Like Sriparna Saha and Snehanshu Saha both are S Saha. So how did you separate? Like if you see I think in Google Scholar page, there are many papers which are not written by me, but they still index in my. They have just added those papers with my entity. So how did you disambiguate this? This is called
name
the entity
entity,
yeah,
name entity distribution. Yeah.
entity
So actually,
disambiguation problem. So how did you solve this?
if you really see, we have collected the data from Google Scholar, which means to say the information which was there in Scholar, we computed only that information. If I want to take it further, if I want to see, okay, there could be many more publication in this name which is not here, which is not in Google Scholar, which could be in Semantic Scholar, then I will have to scrape Semantic Scholar and collect the data from there also. But the whole idea was not to, I mean, definitely to cover as much as possible. But if we could not collect all of the data, then the whole idea was to collect whatever we have and have the familiarity with the scores which are already existing. For like we have compared the results with the SciMago journal and country ranking portal. So whatever results were there, we were able to compare it. So
Sriparna was asking a different question. Sriparna is asking, so let's say there is a paper by, I mean, because
Understood.
the way citation information is usually, particularly if you are just scraping the BibTeX file. But Sriparna,
Yeah.
we were not just scraping the BibTeX file.
No, 1 minute. I have understood.
So we were actually scraping from the journal page also.
Oh,
So
okay.
So if you scrape from the BibTeX file, even then there is a solution. I think there is a Bayesian prior-based maximum likelihood estimation solution which disambiguates between the first names. I know the kind of problem that you are talking about. We did not have to do it because we were also scraping the first page of the journals.
Okay. No. Like maybe here Snehangshu Shaha and Stiporna Shaha are different, but there are multiple authors with the same name, like Stiporna Shaha. There is another faculty in
we did
West
not
Bengal.
consider.
Yeah, so
Right.
that could be a kind of problem.
Yes. There is another Siparna Shaha in West Bengal University of Technology.
Yes.
I know.
Yeah,
I
so
know.
maybe you have to see the affiliation, etc., the email
Right, exactly.
addresses.
So we did that.
Yes,
We
we
checked the
actually did
affiliation.
that.
We checked the affiliation as well. Okay.
Yes.
So because the data which we collected has all the information about the authors and the journals with their affiliation information, with their country of origin and everything else. So it took care of that.
Okay. Yeah, understood. Okay, and in the slide number 35, when you have shown the impact factor, you mentioned that you normalize the impact factor. So how did you
1
normalize
minute.
them?
Yeah, sure. I'll just take that. Just 1 minute, I think.
Max mean, I think. I don't remember exactly.
No,
I think it is the
we divided it with the largest value. I'll tell you.
Okay. So just the max value.
Yeah, we actually divided it with the largest value. Here. So the largest impact factor for this was whatever was the information we divided it. We divided all of the impact factor with that larger value, and hence this became 1.
Okay.
Yeah, normalized between 0 and 1. Suparna, the reason why we did that is because since we had to compare it with JIMI. Now, JIMI, what we did was we normalized each of the indicators between 0 and 1. Right? And COP-Douglas, the way it is that it is a product of 4 variables, each having values between 0 and 1. So when you take the product, it will be between 0 and 1 only, right? So the Journal Internationality Modeling Index, whatever Archana came up with, those values are always coming between 0 and 1. So in order for a fair comparison, we had to normalize the impact factors as well. So that normalization also we brought it to the range of 0 and 1.
Okay, understood.
Just for fair comparison.
Yeah, and you mentioned about the OCQ, and also you mentioned so how did you calculate OCQ values?
So OCQ is basically, I'll take you to that place.
Yeah,
so what we are doing is, so we are just penalizing the total citations, which includes some amount of self-citations because of the authors. They are citing their own self, and hence we have removed this. So how have I computed it in this way? So what did we do? We computed the self-citation in that particular year, divided it with the total citation, and that became 1 minus self-citation divided by total citation. I think this is what it was. This is what we did last in this particular thing. So we computed the self-citation divided by total citation, and then we subtracted it with 1 to compute other citation, because we are interested in knowing what are the citations which are excluding the self-citations.
Okay. Yeah. Okay. These are some minor queries that I had in my mind. So yeah, thanks for clarifications. Yeah. So I am done.
Okay, great. So the remaining formalities we will communicate with you over email. Suparna?
Yeah. Yes. Thanks. So we should declare now Archana that now she is Dr. Archana Mathur. Yeah. Heartiest congratulations.
Congratulations, ma'am.
At the mercy of the university, of course. But yes, I mean, as far as the torture from her advisors are concerned, it's over.
No, to be fair, also, I mean, I never intended to, nor did I torture. Right? I mean, that was exclusively the preserve university.
There is always one good thing about being a Bengali. Okay, there are several bad things about being a Bengali, but there is always one good thing about a Bengali, that they can be quite nagging until they get what they want, right?
Anyway, to put a positive spin on this whole experience, I think you can safely say that at least empirically, it seems to be far more difficult to get a PhD from VTU than MIT. Right?
Yeah, have to agree with that.
Yeah,
I mean, for very, very different reasons, perhaps, but yeah.
So this is like a manifestation of the multiverse theory, like 2 very different reasons that make up the difficulty of getting a PhD.
Right.
I don't know, it's just
Yeah, of course. Okay, thank you so much
Yeah.
for joining. Thank you so much. Thanks, Sriparna, for the time.
Yes.
And
Yes.
I'll have a separate chat with you tomorrow or day after.
Sure.
Yeah.
Sure. Sure.
Okay.
Sure. Yeah.
Thanks, Anand.
Congratulations,
Thank you,
Manchana.
everyone.
Yeah.
Congratulations, Dr. Archana.
Thank you, thank you,
Thank you,
everybody.
Sandesh. Thank you.
Yeah,
Thank you. Thank you
congrats,
all.
Archana, and yeah, Dr. Mathur, just to sort of saying, finally, right? Thankfully, the gods above have smiled and allowed this to go through. And
Finally, we saw the light at the end of the tunnel.
yeah, yeah.
In every conversation, there was light at
Congratulations,
the end.
Dr. Archana Mathur,
Thank you,
madam.
sir.
Yeah.
Thank you, sir.
Thanks,
Thank you, sir.
thanks, thanks for becoming doctor.
Yeah.
Okay, it will
Thanks. No.
add this one to the NMIT.
Thank you, sir. Thank you very much.
Thank
So
you, sir,
Sanjay will be
and Anand,
happy
sir.
that one more
Yeah, one
PhD
more
candidate
PhD
in
is
your
added to my department.
department addition.
Yes,
Very
yes,
Oh,
yes,
nice.
that's
yes.
the two cousins are here. I didn't notice.
Oh my God.
Right? You guys are cousins, right?
Yes. Yeah.
Two cousins are here.
Me and Sandesh are cousins.
I know.
Classmates.
Thank you, sir. Thank you for being here. Thank you
Thank you,
very
Nice,
much.
everyone.
nice work, Archana. And I
Thank you.
really liked, and I really, congratulate you on getting your PhD today and becoming Dr. Archana Mathur. And I could see that Saha has pushed you a lot, and probably you bought in. You thought of using that activation functions. Then from the economics, you're bringing some models and implementing it in the computer science. Really good work. Congratulations once again from my
Thank you,
side.
sir. Thank you. Thank you for being there and thank you for listening. It means a lot. Thank you very much.
Thank you. Okay,
Thank
I'll stop the recording now.
Yeah, thanks a lot for everyone. I mean, of course, Snehan Shui extended the invitation, took care of that logistics, but still, you set out